Hello everyone, and thank you for joining me today. My name is Alex McClure, and I'm a Principal Business Development Manager here at AWS. I specialize in helping companies plan and implement successful AI and machine learning strategies. This session is for business and technology leaders alike who have goals around solving important business problems by utilizing machine learning. Whether you're shaping your organization's culture, planning out a machine learning project roadmap, or influencing your company's technology choices, we'll be talking about the principles and key strategies that are involved with building an organization that's capable of running multiple successful machine learning projects simultaneously. I'll end today's session by talking about some practical steps that you and your team can take to get started, as well as providing a summary of various AWS resources that can help you and your team with your journey towards achieving machine learning at scale. For this session, it will help if you already have a basic understanding of cloud computing and machine learning, but we will be staying fairly high level today. I won't be going into any deep technical or code level concepts. Now, my hope for those of you who are watching this is that this short presentation and set of slides can serve as a tool for you and your teams. I'll be listing several tooling recommendations, process best practices, and organizational recommendations. And I would encourage you to talk about these with your team leaders. Now, achieving machine learning at scale is really about enabling two important groups to achieve the best of both worlds. At a high level, we're talking about enabling data scientists and business stakeholders with the tools and processes that they need to stay agile, while simultaneously enabling cloud IT members who need to ensure high levels of governance, security, and operational readiness. Both groups have needs that are important, yet sometimes it seems like one has to be traded off for the other. But the reality is, you can have the best of both worlds. And as the name implies, we're talking about enabling organizations who are maturing beyond their first project or two, or even beyond their first team or two, and really beginning to look at working on multiple projects across multiple teams. To do this right within a large organization is so much more than just basic data science concepts. Implementing a successful machine learning strategy requires executive and stakeholder alignment. It requires forming cross-functional teams that are all focused on security and compliance. And there are aspects of model lifecycle development that demand high levels of experimentation and discovery. Now, for any company that's operating at scale already, they would tell you that achieving that maturity level required going on a journey. And for most organizations, that path looks a little bit more chaotic than a simple, straightforward line. But we can learn from companies that have gotten this right. Now, in our engagements with thousands of customers, both enterprises and startups, we've observed a few common trends for what it takes to build organizations with successful machine learning cultures. And when we learn from those commonalities, we can see a pattern of 7 key steps emerging. From establishing culture to enabling teams, this journey starts with the human element. From there, I'll talk about best practices for enabling your organization with access to data, both for the proof of concept phase as well as beyond. We'll talk about how to do your first proof of concepts to set you up for success later. And once you're successful with your first proof of concept, we'll talk about how to repeat this process and make sure that you can reliably operate at scale. I want to share 2 quick stories of companies that we've helped, who we started helping after their POCs. In both cases, I should say, these companies asked for help after their first attempts of doing things on their own. The first was a software as a service company out of California. They knew that they should begin exploring AI and machine learning, but they didn't have clear goals in place. So they acquired a local data science startup for their data science talent, and they asked them to spend a year trying to solve problems that would add business value. But at the end of that year, there was really nothing to show for it. Why is that? Well, it's because the team was off completely operating in a silo. They didn't have access to real production data, and they didn't even have access or a clear understanding to the business problems that the company was trying to solve. They came up with some interesting ideas, sure, but nothing that showed business value or a return on the value of purchasing that startup. The second example was a SaaS company out of Canada that spent 6 months trying to develop an intelligent search experience within their product, only to be outdone by a software engineer that was able to implement a heuristic-based solution within about a week. In this example, the simple question never got asked. What's our goal, and what would be the best way to accomplish that goal? In reality, there are some great use cases for machine learning and artificial intelligence, but there are plenty of use cases where alternative approaches do just fine, and they may be simpler and faster. Understanding when and when to not use machine learning is critical. Now, if you're helping your company with your machine learning and AI strategy, I want you to be successful, and I want your team to be successful. So the principles and strategies that I'll be sharing during this presentation are a culmination of best practices that we've learned from helping thousands of enterprise companies and startups with their machine learning journeys. So as with any new initiative, one of the fundamental keys to success is establishing team norms and expectations from the onsets. One of the best things that executives can do for their organizations is to define clear goals and expectations for what you want your machine learning team to accomplish. Let's demonstrate that through a simple example. Let's say that your data science team is tasked with coming up with a churn prediction model that's capable of informing your customer success team as to what insights about which customers your customer success team should proactively reach out to. What type of prediction accuracy rate will drive a significant impact for your business? How often will your product organization be able to update the model that you collect in order to run it through your machine learning models? These are just a couple of example questions for how to drive alignment across your various teams for one use case. Now, yours may look different, but what it should have in common is that your team knows that they're working on the right projects with the right expectations. Successful teams also take a security-first mindset. With machine learning, your data scientists and machine learning engineers are going to take and process huge data sets through advanced computer algorithms. And those data sets tend to be production data. More often than not, that data is either about your customers, your products, assembly lines, supply chains, etc. So you need to manage and govern that data the same way that you do with your other production systems. Now, good leaders also know that when it comes to data science, well, as the name implies, it's a science. And as with any science, this may involve going into the unknown. Your teams may be trying to solve a problem that they've never solved before, so they'll benefit from being given time to learn and advance new skills that are both technical as well as domain related. It's usually very hard to know exactly how long a machine learning project is going to take. And so the data scientists that are working on these projects may need time allocated in ways that's similar to how your other R&D groups allocate their time. Perhaps heavier on the research side of things, as opposed to following a traditional Scrum or waterfall method. Now, by implementing a repeatable MLOps practice, you'll be able to automate what would otherwise be repetitive manual tasks. And that helps accelerate your teams to focus on what adds unique value to your business. Lastly, the best teams know that they're the best because they know what they're being measured against. Maybe it's a computer vision object detection accuracy rate, or maybe it's a product personalization engine that results in increased sales and revenue. No matter what the use case, success should be measured and celebrated when it's achieved. Now, I start this presentation and call it step 1 as though it's a step that actually gets finished. But in reality, establishing culture will permeate all of the other steps. It has to continuously be prioritized, discussed, and improved as time goes on. Now, to make one last team sports analogy, I want to speak to anyone who has ever gone rafting with a boat team. As you know, your team and your boat may not go very far if everyone is rowing in different directions. The only way to get through the turbulence is to row together in the same direction. So the typical machine learning project involves bringing together several various roles to form a functional virtual team. We see team members coming together who have data science skills and DevOps engineering skills. At some organizations, you may see team members who have all of those skill sets. But when you're operating at scale, we typically see teams being a little bit bigger. I'm going to highlight some of those key roles and briefly mention some of the others that also get involved. So starting on the left, let's talk about data engineers. Data engineers are responsible for sourcing and providing data to your data scientists. Your data engineers will be extracting and transforming data from your other production systems or production databases and providing that to your data scientists in a way that can be easily consumed. Data engineers need robust data processing tools and the ability to quickly visualize your production data. From there, let's move to the right and talk about data scientists. Data scientists are generally the ones who make sense of your data. Maybe they identify insights or patterns that otherwise go unseen, so as to improve or create business processes. Data scientists need access to data and powerful computing environments to build, train, and deploy machine learning models. And that's where tools such as AWS Sagemaker can help accelerate your day-to-day operations. Frequently, data scientists may work alongside software engineers so that your other systems and applications can integrate and make use of your other machine learning models. Now let's go down to your DevOps engineers or perhaps your IT admins. These foundational critical teams are going to be doing work such as configuring your AWS accounts and environments, enabling your other groups with monitoring and logging capabilities, and automating your deployment pipelines. And of course, they'll also be working hand in hand with your security engineers who are putting in place the right policies, alerting rules, and reports in place to ensure that all of your other teams are treating your data with the same safeguards and precautions that you do your other production systems. Now, if your organization doesn't have all of these roles, that's okay too. And actually, that's where organizations can get the most leverage out of using managed machine learning services such as Amazon SageMaker. SageMaker simplifies the end-to-end process of building, training, and deploying models. And I'll talk more about SageMaker later on in this presentation. Now, one thing that can drastically help your teams be successful is if they're surrounded and supported with domain experts who are knowledgeable about the topic at hand. Now, it's probably obvious. This diagram isn't meant to illustrate every single last role that's involved with machine learning projects. You'll, of course, have product managers, project managers, business stakeholders, QA roles, etc. that commonly get involved. The diagram is really just supposed to highlight the most relevant roles from a technical perspective. But overall, that close partnership between your data science organization and the domain experts that they're building models for will give your organization a head start for overcoming organizational inertia. And overall, when both teams are coming together more closely, you'll get better bide sharing and adoption, which you'll see happen much faster than without. Let's shift gears and talk about your data strategy. So what's our goal again? It's to create machine learning models. And how are models trained? Well, the same way that the human brain is trained. We gather input data, such as what we hear or what we taste, and then we're told what an object is. If you speak English, for example, you'll think that an airplane is an airplane because that's the label that you were taught or that you were given. Machine learning models work in much of the same way. You bring labeled data through a computer algorithm, and end up with a model that's capable of labeling new, unseen things as long as they're similar to the training data and labels that you built your model with in the first place. So when you're at this initial phase of planning your next machine learning project, it's important to think about what access do you have for data today? What data can you easily make available to your data science teams? Or if you're starting a new project and you're starting to collect data today, what would you be able to make available to your data science teams, say 6 months from now? So let's say that you have an initial data set. Has that data been labeled? A lot of common machine learning projects require what we call a training data set, where each entry in your data set has a label attribution. For example, if you're building a model that's capable of detecting fraudulent transactions, you need to start with a data set of known transactions that are labeled as being either fraudulent or legitimate. If you're building a model that's capable of predicting whether customers are going to churn from your platform or not, you need to start with the data set of customer entries that are labeled as being churned or retained. And you want all of that data to be readily accessible and consumable, usually through a data lake, hosted on Amazon S3, for example. Now, those principles are common to machine learning. And remember, if you want your machine learning models to be effective in production, that means that they need to be trained with production data. It will help improve their accuracy and effectiveness. But let's talk about some of the core concerns that are important to think about as it relates to managing that data, which is data security. Now, this is a step that unfortunately commonly gets overlooked, particularly in scenarios where large companies absorb startups for their talent acquisition purposes, or even organizations that hire project teams all at once very suddenly. I hate to say it, but this happens fairly often out in the real world. Data scientists will download production data onto their laptops or desktops to work on their projects. But that's a risky approach. You really should be treating your production data with the same level of governance that you do your other production systems. And there's two common approaches to help organizations achieve this. The first is that you can set up a separate sandbox environment for your data science team. Tangibly, that looks like setting up an entirely separate AWS account, perhaps with multiple identity and access management users and roles. With this approach, you would copy data from your production environment into your data science sandbox environment. Now, the benefit to this approach is that by having a separate sandbox environment, you limit your risk of accidentally destroying data or overloading your production systems. The downside, however, is that by having multiple environments with the same data, you may have additional administrative overhead when you want to take action or do certain data management tasks. For example, let's say that you have to comply with a GDPR request to delete a customer's data. Or maybe you have to update data records after they get written the first time. How do you ensure data consistency across multiple accounts? And how do you govern your data across multiple accounts? All of it's possible, it just takes additional extra data management tasks. The second approach is to establish a data platform account and service. This would involve giving data scientists read permission to that data platform. The benefit to this approach is that it simplifies the data governance and data consistency concerns. The potential downside, however, is that if you don't set up all of your roles and permissions correctly, you could inadvertently have a user that accidentally deletes data in production. Or you could overburden or tax your production systems by unexpected usage patterns. Now, when it comes to equipping your teams with data that they need to be successful, it's also worth highlighting another challenge that you may run into. It'd be nice if all this data was sitting perfectly in one database or one S3 bucket, but in reality, it usually never is, especially for enterprise companies. Getting your data scientists access to data that they need in the time frame that they need will usually involve aligning various business and IT stakeholders. So to get access to that data, you may need to even break down organizational silos or political policies, depending on how your organization treats data ownership and governance. That's one of the reasons why we recommend starting with this step as early in the process as possible. Now, most of the information that I'm sharing in this presentation is geared towards organizations that have already completed their initial proof of concept and are trying to get past that point. But just in case you're still at the proof of concept stage, here are some considerations that I strongly recommend you evaluate when planning a proof of concept. First, instead of starting with a generic, irrelevant data science project, I recommend starting with asking the question, what business impact are you trying to make? Maybe you're trying to automate a business mechanism that's done today in order to achieve better efficiency gains. Or maybe you're trying to create a new capability for your users and applications that doesn't exist today. Either way, it's good to start with defining that problem and creating a baseline for how well you solve that problem today and setting a goal around the gains that you want to make by using machine learning. Another way to think about those goals is, what would be the minimum amount of business value or improvement that you would need to create in order to justify doing things differently from how you're already doing them today? There are two other important pieces of success criteria that need to be planned for at this stage. What accuracy rate do you need your model to perform at? And once that model is built, how quickly do you need it to be able to make predictions every time you feed it your input data? Now, the answers to those questions can have a huge impact on whether your project is successful or not. You may have an extremely accurate model, but if that model is slower than your acceptable user experience SLAs, you could have a problem for your customer experience. If that's the case, what are the trade-offs that you're willing to make around prediction accuracy versus performance? Now, we spent just a few minutes talking about what your typical team makeup will look like, as well as what successful organizations think about when it comes to data. But for proof of concepts, data will typically be pulled and collected manually just once for your first project. Your team will probably utilize that model that they create manually, as opposed to spending a lot of time embedding it within your production systems. The last thing that I want to highlight here is that it's important to think about how long you can take with this proof of concept. Now, there's no hard or fast rule for how long proof of concepts take, but from what we found, it usually takes somewhere between 2 to 6 months for companies to complete their proof of concepts from start to finish. That timetable may differ from company to company or project to project, depending on whether your team is already formed, if you already have all of your data prepared and labeled, and if your security and governance policies are in place or not. The main thing here is that proof of concepts should not drag on indefinitely. And if they do take longer than 6 months, or if you find that your budget is escaping from you, it's worth asking if the goals are too aggressive, or if you don't have the right data, technology, and processes in place. Now that you've completed your proof of concept and have a functional, useful model, it's time to begin thinking about introducing automation so that your steps can become more repeatable and more automated. A key difference between the previous step and this step is that for your proof of concept, you probably pulled your data set manually as a one-off exercise. But if your use case requires you to make inferences and predictions on a regular basis, say during nightly batch jobs, you may want to automate your data engineering steps. Now, the key to building a successful, repeatable pipeline is to first treat your machine learning infrastructure as code. That way, your entire end-to-end pipeline can be executed upon significant events, whether it's a predetermined schedule, a new data set coming into your data lake, or a monitor that determines whether your model is no longer performing up to your accuracy SLAs. A typical pipeline might have a dozen or more steps, which you see illustrated in the diagram on the screen. And these steps can then be defined, executed, and tracked through tools such as AWS step functions, the data science SDK, and CloudFormation templates. There are many ways that these orchestration systems can integrate with Sagemaker, but those topics will be covered in depth in other reInvent sessions. So to start with, let's recap on the roles that we typically see making up a machine learning project team, as well as the responsibilities that each role is responsible for when it comes to operating at scale and bringing automation in at scale. Although you may have additional product or program managers involved with this, core teams, when you're operating at scale, typically include at least data engineers, data scientists, software engineers, DevOps engineers, and security engineers. But when organizations are really ready to begin operating at scale and expanding beyond their first project, or even when you're ready to have multiple teams working on multiple projects, your teams will look a little bit different. As you scale, we would encourage you to establish a Machine Learning Center of Excellence, or COE, that provides foundational support to all of your other machine learning teams. Now, a good center of excellence can provide a lot of help in different ways, many of which I list here. COEs help put standard tooling and processes in place for the rest of your other teams. They may also work with various products and business groups to ensure that projects are being scoped with good goals and expectations. Hopefully, they'll be establishing a common data access platform and providing oversight in which other team members can access data repositories with the right security and governance in place. Now, we recommend that your COE be a cross-functional group of individuals who are also part of your actual delivery teams. You don't want your COEs to be too far away from reality of the types of projects that your other teams are working on. One strategy that companies can take to solve this is to rotate your COE members in and out of other project teams and the COE every 1 to 2 quarters. Another way is to dedicate representatives to work on individual projects and COE tasks. Now, either approach you take, the primary recommendation here is to ensure that your Machine Learning Center of Excellence members stay engaged in projects, otherwise they might fall out of touch with the realities of those other teams. Now, there's one more important principle I want to unpack before saying that the journey is done. And that principle is that in reality, this process looks a lot more iterative than it does linear. Organizations evolve over time by embracing an experiment and iterative-based development process. So that's why, going back to our cultural principles, it helps being experimental in nature. So how do organizations implement experimentation into their culture? One technique to do that is to enable data scientists with the ability to deploy models into production in a way where they utilize true A/B testing. With that method, you can test how new models perform in production in a way that only impacts a very small, predetermined percentage of your traffic. Another technique is to utilize a shadow deployment pattern, where your production application makes requests to 2 models. And from there, you may show your user the result of your known proven model, while you simultaneously store the result of your shadow model inside of a data store that you can utilize later. So far, we've talked about a lot of principles and strategies involved with operating machine learning projects. Let's shift gears a little bit and talk about tooling. And in particular, I want to highlight our primary managed service that has helped some of the world's largest organizations with their machine learning projects. And that tool set is Amazon Sagemaker. Amazon Sagemaker is a fully managed service that provides every developer and data scientist with the ability to build, train, and deploy machine learning models easier and faster. Sagemaker removes the undifferentiated heavy lifting from each step of the machine learning process, as well as the infrastructure management, to make it easier to develop and deploy high-quality machine learning models. Now, traditionally, before Sagemaker, the machine learning development process was complex, expensive, and made even harder because there was no integrated tools for the entire machine learning workflow. Prior to Sagemaker, teams had to stitch together all of their own tools and workflows, which was time-consuming and error-prone. Sagemaker solves those challenges by providing all of the components used for machine learning into a single toolset so that models can get to production faster with much less effort and lower overall cost. Tens of thousands of companies have used Sagemaker to build, train, and deploy machine learning models. One example that I particularly like is from Intuit. Intuit developed machine learning models that can pull a year's worth of bank transactions to find deductible business expenses for customers. Using Sagemaker, Intuit reduced their machine learning development time by 90%, from 6 months down to 1 week, using the ML at scale principles and strategies that we talked about in this presentation. Another example is GE Healthcare. By using Sagemaker and the patterns and practices described in this document, GE Healthcare was able to significantly advance and improve their patient care. And it's incredible just how many customers have started using Amazon Sagemaker. We have tens of thousands that are standardizing on top of Sagemaker for their machine learning tooling. Avis, Bristol-Myers Squibb, Chick-fil-A, Condé Nast, Dow Jones, GE, Hearst, Liberty Mutual. If you look across the board, it's a very broad group. I mentioned at the beginning of this session that my hope for those of you who are watching this is that this short presentation and set of slides can serve as a resource for you and your teams. I'd encourage you to talk about these ideas with your team leaders. We wanted to share the most pertinent best practices from the world's most successful machine learning organizations and the practices and strategies that they have cited as being game changers time and time again. Now, if you are serious about getting started, there are a lot of AWS resources that are available to help. You can talk with your AWS account executive or solution architect to learn more about any of these resources. Our virtual Machine Learning Immersion Day events can help train your team on all of the various technical capabilities that we talked about today. And if you're just getting started and need help establishing a plan for a successful proof of concept, talk to your AWS account manager about setting up an ML workload design workshop. Or if you're working on a time-sensitive project and you need to augment your staff with professionals that have proven experience, you may want to consider working with the AWS Machine Learning Solutions Lab or an AWS AI and ML partner. We have a lot of certified AI and ML partners within our partner network, many of whom have offices and teams from all over the globe. These partners can help with all aspects of your machine learning journey, from initial ideation through training and even advanced MLOps concepts. So there's a lot of resources available to help you and your teams be successful with machine learning on AWS. If you want to get started, the best way to connect is by talking with your account executive, who can connect you with any of our specialists in this space. And with that, I'd like to thank you for watching the session today. I hope that you found this information useful. In fact, we'd love to hear from you and know what you thought about this session. So please be sure to complete the session survey. Thank you again.